So we've talked about the definitions of odd and even functions and how to prove if a function is odd or even. What I'm going to do in this video, I'm going to give you a couple of examples. What I'd like you to do is pause the video, have a crack at the questions, proving if they're odd or even, and then check your answers against what I'm going to show you in the video after. So here they are. So I want you to classify each of those four functions as either odd, even, or neither odd nor even. So pause the video, have a crack at all four of them, then come back and see how you got on. So the first one, f of x equals sine x. Now remember, for any of these three, we always start with f of negative x. That's always our first port of call. So what we start with is f of negative x, and that equals sine of negative x. Now if you think about the symmetry within a sine curve, let's imagine we take sine of pi. Well, we know then that sine pi is equal to sine of 180, which is equal to 0. So sine pi is equal to 0. If we were to do sine of negative pi, and we were to work it back the way and look at the diagram, that would also equal 0. So it almost looks like the two of them are the same. But could that hold for every value? Well, let's check a different value. Let's imagine I do sine of pi over 2. So that's the equivalent of sine of 90. Well, we know sine of pi by 2, that's equal to 1. If I then go back pi by 2 from the 0, and I do sine of negative pi over 2, well, that is equal to negative 1. So what that means is if I take my pi by 2 as being x, sine of negative x is equal to negative f of x. So what that means is f of negative x equals negative f of x for the sine curve. So what that means is I can then say that sine of x is odd. It's actually quite straightforward if you think about the symmetry within the curve. If I was to roughly sketch a sine curve, I know that it would go on as a wave like that, but I could also continue backwards beyond 0 in the same sort of fashion. If I was to pin that down at the origin and turn it a half, I would get half-turn symmetry, so it's an odd function. Second one, f of x equal to cos of x. Again, we start at the same one, f of negative x. So that is equal to cos of negative x. So what I now want to do is start to think about values of x, and let's see how they hold out. So let's say I do f of pi over 4. What that means is I'm going to do cos of pi over 4. Now pi over 4 is the equivalent of 45 degrees. I know that cosine of 45 degrees is 1 over root 2. Then let's imagine I do f of negative pi over 4. So then cos of negative pi by 4. Let's sketch the cosine curve and see how that would play out. So we know it's a rough sketch. I'd do that with cosine, but if I went back below 0, I'd still get the same sort of shape. If I put a line horizontally at 1 over root 2, I know that above 0, it would cut at pi over 4. But below 0, this first cut where it would be there is at negative pi by 4. So the value at negative pi by 4 is the equivalent of the value at pi by 4. So at negative pi by 4, I'm also going to get 1 over root 2. So what I've just shown there is that f of negative x is equal to f of x. I get the same value for both, so using my definition I can say therefore it's even. I know that cosine of x is an even function. Third one here, f of x equals x minus 1 over x squared. Again, start at our usual place, f of negative x. What I then get is like negative x take away 1 over negative x squared. So that equals negative x take away 1 over x squared. Now I could look at that and think, well, if I take out negative 1 as a common factor, I may very well end up getting f of negative x equals negative f of x. So if I do that, I get negative bracket x plus 1 over x squared. But that is not the equivalent of negative f of x. And I know the previous line, negative x take away 1 over x squared, is not the equivalent of f of x. So this function here, I know I can quite simply say it's neither odd nor even. Final question here, the d f of x equals e to the x plus e to the negative 2x. If I again start with f of negative x, what I end up getting is e to the negative x plus e to the negative 2 times negative x to the 2x. Now, in this sort of function, e to the negative x equals e to the x at only one value, and that is when x is equal to 0. They both cut the y-axis at 1 when x is equal to 0. However, if you look at the shapes of the curve, e to the x goes up that way, e to the negative x comes down that way. So they're not the equivalent curve. So what that then means is that we're not going to get f of negative x is equal to negative f of x, and f of negative x does not equal f of x. So what I can then say is it's neither odd nor even. So for each of these functions, I've looked at the steps involved in proving if they're odd, even, or neither. The first step is the most vital. We always start with f of negative x. If we start with that, substitute in the negative x to the function, and work it through, we will get one of those three solutions. We'll either prove that f of negative x equals negative f of x, so it's odd, f of negative x equals f of x, so it's even, or it won't satisfy either of those two conditions, and we'll end up getting a function that is neither odd nor even. The types of symmetry associated with this just make our life a heck of a lot easier when it comes to sketching curves, so this is a key point to remember.